Okay, I am back.
Okay. Right.
All right, so where were
So
we? So I
moles and
gave
molecules,
you
you said, let's say,
this
yeah,
first. Yeah, so I gave you this first. So before we even go to moles and molecules, I I said the first step is to
balance.
okay. So step one, you're gonna balance.
Mm. Step two, then your ratio.
All right, so we start with step one.
Mm.
So how did
Should
you
be
balance it out?
should be C3H8 plus 5O2 reacts to form 3CO2 plus 4H2O.
All right. So, firstly, you are explaining it to someone now who did not do the first sessions. So, what you look at how many hydrogen you said 8 here. Then here you look at you have 2, so to get 8, what did you put here?
4.
4, right? So now
Mm.
once you put 4, you end up having 4 oxygens and then 4O, and then here you have 2, and then that's 8.
Mm.
So what did you end up doing?
There's a 3 before CO2 as well
Okay, so you put a 3 here to
to
get
balance
this
the
the
carbons.
carbons, and
Yeah,
then
and then
that
oxygen becomes 6 and 4, 10, so 5O2.
all right. So that becomes 6 and 4. That is 10. Then to balance out, you put 5,
Mm.
right? And then that means your equation is balanced. So
Balance.
now that means we are working with this equation.
Mm.
So we have our equation as that now.
Mm.
Okay, so let me write our new equation here. So we have C3, 8 plus 5 oxygens, 3 carbon dioxides, plus 4 molecules of water. All right. So we go to 2.
Mm.
So now we're introducing the word molecule, right?
Yeah.
So now what does molecule mean before you answer how many molecules you have?
It's a combination of two elements,
All right.
a
So
bond between
it's
two or more.
combination of element of atoms or
Mm.
particles. It's a combination, but if you have the word combination, connection, you know how your first part of chemistry you would have bonds like that. Let's say CH H. You see that?
Mm.
So that is a molecule,
Mm.
right?
Yes.
So there's a combination of atoms here, right? So
Mm.
this means C3H8 is a molecule, right?
Yes.
So now we want to interpret it in terms of molecules. So we're going to say
Mm.
we have one molecule
Of C3H8.
of C3H8,
H8.
right?
Mm.
We have plus 5
5 more.
molecules
O2.
of O2.
O2.
And those give us
3 molecules of CO2 and 4 molecules of H2O.
right.
Mm.
And then now we go to part 2. I mean,
Part 3.
3. We're interpreting the equation in terms of moles.
Mm. Is there any difference?
So what are moles?
Uh, a ratio, I guess. I don't know what amount.
So what did we say moles are when we were doing, what did you interpret when we said there are 5 moles, 4 moles? What were we saying?
Number of molecules. or number of, well, how can I say this? Number of those combinations needed.
Exactly. It's we use it like not a metric, but it's a number to quantify. The word quantify, it's to count how many of whatever we are doing, but in this case it's how many molecules are there, or particles, or whatever, right? So it's a
Yeah.
number of molecules. It's used to count things, right? Remember we said molecules. When you wanted to say molecules and moles, won't it be the same? In this case, yes, but moles and molecules are two different things. Molecules, we said it's a combination of atoms. It's that connection that is a molecule. But moles, it's used to count. It's like, I don't want to say it's an SI unit. It's not an SI unit. It's a metric. You know when you're saying that dozen of something, dozen of that, there's the tons of that. It's used to count. Ne? So
Yeah.
in this case, we are counting C3H8, which is our molecule in this case. So how many moles do we have of C3H8?
One. One.
Yeah, I thought you were saying four. We have one. We have 1 mole of C3H8. That is plus
5 moles oxygen.
5 moles
Oxygen.
ox- yo- oxygen to give us 3 moles
CO2.
CO2 plus 4 moles of H2O. Right. And you are done. So that is for the moles,
Okay.
right? Then we go to,
The grams don't balance, so they like 0.2 off.
maybe you left out a decimal somewhere, but we'll get there.
Okay.
Let's see. So that is the moles, right? We understand the moles. So now we want to verify that the mass is conserved from what you are saying. The first part now, when we are dealing with mass, so we are for mass now. I'm just gonna copy this here because we are going to the, so that I don't repeat writing it.
Okay.
Right? So we are dealing with mass. So we want to verify that the mass is conserved. Maybe the question will be, is the mass conserved in this question? Yes or no? So we have to first
Okay, continue.
we have to first convert the moles of reactants and the products to mass by the conversion factor that we did. So I would want you to do it. So we're gonna run through what you did. You said what? So that we get to what you are saying that it's out.
Okay, C3H8, you said mass is just 44.09. 1 mole, it's just gonna stay 44.09. And
Okay.
then, yeah.
So we want to have step by step. We want to calculate the mass of this reactant, right? And you are
Yeah.
saying, how many moles do we have? We said we have 1 mole of C3H8, right? So now we have to multiply by the mass of, we said 0.9 of C3H8. And then we have
Yes.
that mass per 1 mole of C3H8. Don't want to be writing this all the time. So this and that, those will cancel out, right? And then this will stay as 44.09 grams of C3H8.
Mm.
Right? Then we go to
Yeah.
O2, oxygen. So we're calculating now the mass. You've already done this part, right? Of
Yeah.
oxygen. Just writing it step by step.
32 times 5.
So we say we have 5 moles first of oxygen from the
Mm.
given equation, right? And the mass of each mole of oxygen is 32 grams. This
Mm.
is for each mole of oxygen, right? So
All
that and
right.
that will cancel out, and then we have 32 times 5.
160.
This is 160 grams of oxygen on this equation. So we are done with the
Reactants.
reactants. So we have
Two.
44.09 plus
Yeah.
160.
It's 204,09.
So the reactants, let me write it here because that one is up there now. Said plus 160
Should just be
grams.
204.09.
We have 204.09.
09.
We can round it up to 1. And then this
Okay.
is for reactants,
Now,
right?
if you round up, yeah, then it can work.
Okay, so we have, now we are going to the products,
Okay.
right? So we calculate the mass of carbon dioxide, right? How many moles of carbon dioxide do we have? We have 3
3.
moles, right?
Yeah.
And then what is the mass of each mole? It's 44.01, right?
Yeah.
And then divide by 1 mole. This is for per mole. So that cancels out, and we have 3 times 44, which you got as
It's going to be 132.03.
132.03. This is grams of carbon dioxide in our equation. Then we go to water. How many moles of water do we have? We have
4.
4. So we have 4 moles of water. And what is the mass of each molecule?
18.02.
So it's 18.02, and then it's 1 mole. You know why we rounded it up? Because even the numbers, when you will find maybe it's like 0 point something something, and then you just chose 2 decimals. So this is 72.08. Think, just
18.
confirm.
72,08.
Yeah, okay. So we are now, what is the results of the products?
It's the same thing. It's just 204,11.
Right? So now
Yeah.
we say that 204.1 grams of reactants is equal to 204.1 grams of products. And then we say the law of conservation is observed. Right?
Yeah.
All right.
Yes.
It's what I was saying now, that the sums of the reactants and the products are correctly stated to the first decimal place,
Okay.
because when each mass is accurate to the first decimal place. That's why I was saying you just round it up to the first decimal place to see if the law of conservation is observed.